Hi, I'm John Hayden, showcasing several different AirLogic products here today. We're using our model Corliss engine to do it. This could be any device, whether you have a coffee maker, a ventilator, gas analyzer. The Corliss engine is a fun way to just demonstrate changes in flow rate though, so we like to use that here. So what we have here is incoming air pressure. At our shop we use 120 PSI. It's a basic on-off valve. We use a small filter. This isn't required, but it's best practice to put a nice filter in front of any type of critical control devices. Here we have our regulator. It's going to drop us down to about 20 PSI. A toggle valve. When I flip this, the incoming air pressure will go to one circuit or the other here, and it exhausts the opposite circuit. And if we follow the path through here, we have a check valve, then an orifice, and then a T. So the check valves are important here because, of course, if we supply air here, we don't want it to come all the way back through this other way. So when we supply air, the opposite check valve will close and the air can only go through into our device here. We're going to turn this on and see if we can run this model Corliss engine at two different speeds. This is our slow speed. So you can see it's running real slow. Let's get a tachometer reading here just for fun. 42 RPM. When this engine would have been running back in the early 1900s, this would have been running at about 100 RPM. And scaled up, this would have been about a 150 horsepower engine. Okay, so let's change the speed and see if we can get this thing going a little bit faster. So we're gonna flip the toggle valve. Oh yeah, we're going faster for sure. So what happened there was we changed what tube the air was going through. We went from our smaller orifice size up to our biggest orifice size. And then the check valves, one open and one closed. The air comes in, goes through the engine, and of course more air, faster engine. So let's get another tach reading here just for fun. All right, 120 RPM. Really cooking here. So that's the basics. I think we'll flip it back to the slow speed. So to show you this, how this thing works again. It looks like a snail's pace now. So this could be applicable in your equipment if you want to run for two different speeds. Maybe you want a maintenance speed and an operational speed, any number of reasons, right? The nice thing about using orifices here is you're always going to get the same flow rate through them. So you know whenever you go to your high speed, it's going to be exactly where you want it, and wherever you go to your low speed, it's going to be where you want it. Of course, you could use some type of adjustable valve here, but then you're kind of in no man's land. This is the way it's fixed, and you know exactly where you're going. So again, I'm John Hayden at AirLogic. These are some of the products that we sell. Come check us out. Really appreciate you watching.